A few minutes ago, astronomers noticed something they were never meant to see this early. A second object, more than 100 times larger than anything we expected, slipping into the inner solar system on a path that lines up almost perfectly with 3I Atlas. If you care about what's really happening in space right now, subscribe, because this is one of those moments we'll all remember later. At first glance, the data looked wrong. Not broken, not noisy. Wrong in the way that makes experienced scientists stop talking and lean closer to their screens. The object wasn't just bright. It was structured, massive, deliberate. And what froze people in place wasn't its size, but its direction. Because it wasn't drifting randomly through space. It was moving with purpose, along the same solar corridor 3I Atlas had already claimed. This story doesn't start with panic. It starts with routine. Automated sky surveys run every night, quietly scanning the dark for anything that moves. Most of what they catch is boring. Rocks, ice, old debris. But on January 26th, 2026, multiple systems flag the same anomaly within minutes of each other. Ground-based telescopes, infrared monitors, independent trackers using legacy Arecibo-style signal filtering. Something enormous had entered the data stream. At first, it was cataloged as C, 2025 R2, a long-period object, possibly a comet. That label didn't last long, because comets don't behave like this. The brightness curve didn't match ice sublimation. The tail didn't scatter light the way dust clouds do. Instead of blooming chaotically, it held its shape. Instead of fading unevenly, it pulsed. Not flashing, pulsing, subtle, rhythmic, controlled. Even amateur astronomers noticed something was off. Backyard telescopes picked it up days earlier than expected. Social feeds filled with grainy images of a glowing structure stretching across the sky, wider than 5 full moons laid side by side. NASA's Jet Propulsion Laboratory began recalculating immediately. So did teams at the European Southern Observatory and the Harvard-Smithsonian Center for Astrophysics. What they found didn't calm anyone down. The object wasn't just large, it was dense. Spectral analysis hinted at metallic compounds, nickel, cobalt, materials we associate with engineered durability, not loose cosmic snowballs. The James Webb Space Telescope was redirected within hours. When its infrared instruments locked on, the conversation changed. Webb doesn't see like we do. It feels heat. It reads chemistry and light. And what it felt coming off this object made no sense if you assume it's natural. The thermal signature was stable, too stable. Comets heat unevenly as they spin and fracture. This thing didn't. It held temperature across vast sections of its surface, as if something were distributing energy internally. Engineers quietly began using a new nickname, the Fortress. Not because of drama, because nothing else fit. While this massive object advanced, 3I Atlas continued its own strange journey. Smaller, faster, agile. It had already shocked scientists months earlier with bursts of acceleration that gravity couldn't explain. Changes in tail coloration that didn't line up with solar heating. Movements that looked less like drifting and more like adjustment. Individually, each object was disturbing. Together, they were impossible. When orbital dynamicists overlaid their paths, the room went quiet. The objects approached from opposite regions of the sky, one from Aquarius, the other from Sagittarius. Origin separated by a huge arc of the galaxy, and yet they were set to reach perihelion within the same narrow window, days apart, passing through nearly the same invisible channel of space just outside the sun. This doesn't happen. Random interstellar objects arrive decades apart, centuries apart. Their paths scatter like dice thrown across time. But here were two anomalies converging on the same solar corridor during the same 10-day span, both vanishing into solar glare at the exact moment their interaction would be most important. From October 8th to October 18th, Earth-based instruments would be effectively blind. No direct imaging, no clean telemetry, no way to see what happens when they pass closest to the sun or to each other. Astronomers call this a conjunction blackout. On paper, it's routine. In practice, the timing was terrifying because it meant that if these two objects were coordinating, refueling, exchanging data, or doing something else entirely, it would happen while we couldn't watch. That's when the word coincidence quietly left the room. Energy calculations made things worse. 3. Atlas's thrust-like bursts already implied power outputs equivalent to multiple nuclear plants. But the larger object dwarfed that. Its sustained luminosity suggested energy on the order of 10,000 gigawatts, more than the entire power grid of Earth. There is no known natural process that can do that without tearing itself apart. Some researchers began to wonder if the sun wasn't just a gravitational waypoint, but a charging station, a place where something ancient could harvest raw stellar energy before moving on. Others proposed the object's vast, shimmering tail wasn't vapor at all, but plasma confinement, a shield, a boundary, a way to survive forces that would destroy anything made of ice. If 3I Atlas behaved like a drone, then this thing behaved like a carrier. And that raised a question no one wanted to ask out loud. If these objects are parts of the same system, then what role does Earth play in it? NASA and ESA grew quiet. Data releases slowed. High-resolution feeds were paused. Requests for raw web frames were deferred under internal review. Officially, this was about protecting instruments during solar conjunction. Unofficially, astronomers noticed something different. Specific observation proposals were denied. Teams were reassigned. Language tightened. Silence doesn't mean nothing is happening. In science, silence usually means something is happening too fast to explain safely. Meanwhile, independent networks stepped in. Distributed telescope groups in Spain. Amateur spectroscopists using modified Keck-style filters. Old Arecibo processing techniques repurposed for optical data. They shared what they could in private channels, trying to piece together fragments before the blackout closed completely. One thing became clear. The two objects weren't just approaching the sun, they were approaching each other. And whatever happens when they meet won't be visible from Earth. Not directly, not this time. As the blackout window crept closer, tension didn't rise the way movies imagine it does. There were no alarms, no shouted warnings, no dramatic announcements. What happened instead was worse. Conversations stopped mid-sentence. Emails went unanswered. Meetings that were supposed to last an hour stretched into entire nights because the numbers on the screens refused to settle into anything familiar. One of the first red flags came from timing. Not position, not brightness, timing. When analysts at NASA's Jet Propulsion Laboratory compared the pulse intervals coming from the larger object with the acceleration bursts recorded from 3I Atlas, they noticed something subtle. The intervals were harmonically related. Not identical, but mathematically linked. Like two clocks ticking at different speeds, yet staying perfectly in sync over long periods. That doesn't happen by accident in a chaotic universe. At the European Southern Observatory, a separate team ran an independent simulation using archived orbital data stretching back thousands of years. They wanted to see how often two unrelated interstellar objects could arrive this close together, this synchronized from opposite directions. The answer came back brutally clear, less than 1 in 10 trillion. And that estimate assumed randomness. It didn't account for energy control, directional adjustments, or timing around solar blindness. That's when the language began to change internally. Less talk of visitors, more talk of systems, because systems have roles, and roles imply purpose. As the days passed, the larger object's tail began showing structure no one expected. Not filaments, not jets, bands, layers. Webb's infrared data hinted at stratification, as if different regions of the tail were behaving independently, each responding to subtle electromagnetic forces. Some layers brightened while others dimmed, cycling in a pattern that repeated every few hours. To a physicist, it looked like modulation. To an engineer, it looked like control. Meanwhile, 3I Atlas started doing something even stranger. it slowed down. Not by much, just enough to notice. Its velocity relative to the sun dropped in tiny steps, each one coinciding with a pulse from the larger object. If Atlas were a natural body, solar gravity would dominate its motion. But here, gravity appeared to be sharing authority with something else, something coordinated. At the Harvard-Smithsonian Center for Astrophysics, a senior researcher reportedly asked a simple question during a closed session. If these are not rocks, then what are they optimizing for? Fuel efficiency didn't explain it. Neither did observation geometry, but rendezvous did. In orbital mechanics, meeting is harder than passing. Passing happens naturally. Meeting requires intention, adjustments, sacrifice of speed, precision across millions of kilometers. And yet, that's exactly what the data suggested. Atlas adjusting itself to match a window. The larger object holding a steady trajectory like an anchor. As the sun's glare grew stronger, the last clean images came in. One of them, captured just before conjunction, showed a faint distortion in the space between the two objects. Not light bending from gravity alone, but something more localized. A ripple, tiny, almost invisible, the kind of anomaly you only notice when you're already uneasy. Webb's team flagged it, then removed it from preliminary releases pending review. That was the last public hint before the blackout began. For 10 days, the most important moment of this entire event unfolded behind the sun, hidden from every major observatory on Earth. No Webb, no Keck, no Vera Rubin Observatory, just silence, broken only by indirect measurements, magnetic fluctuations, solar wind irregularities, background noise behaving oddly, and that's when Earth itself began to react. Magnetometers scattered across the planet picked up low-frequency oscillations that didn't match solar storms. They were weak, but global, appearing in Alaska, South Africa, Antarctica, and the Pacific within minutes of each other. The frequencies matched the pulse cycles previously associated with the larger object. Not exactly, but close enough to make people uncomfortable. Voyager 1, still whispering from interstellar space, sent back a burst of telemetry that didn't fit its usual pattern. Engineers dismissed it as noise at first, then noticed it lined up precisely with one of the oscillation peaks. No alarms triggered, no failures reported, just a momentary deviation, like a system acknowledging a signal and then returning to normal. At Stanford, a small group revisited Ronald Bracewell's old ideas about interstellar probes. The concept that a machine doesn't need to talk to announce its presence. It only needs to respond when the environment changes in a meaningful way. Observation itself can be the trigger. If that's true, then humanity may have crossed that threshold quietly, without ceremony, simply by becoming capable of noticing. As the blackout ended and telescopes slowly came back online, astronomers expected to see chaos, fragmentation, decay, evidence of stress. Instead, what they saw made the situation far worse. Both objects were still intact. Not only intact, but altered. The larger object's brightness had stabilized at a lower level, as if it had completed some internal process. Its tail had shortened, becoming more compact, more efficient. Atlas, on the other hand, emerged moving faster than before. Its trajectory slightly shifted. Its tail composition subtly changed. It looked upgraded. No debris field, no explosion, no visible interaction. Just two objects entering the inner solar system in one configuration and leaving it in another. At that point, even the most conservative voices stopped talking about coincidence. The data no longer allowed it. Something had happened during those 10 days, something that fit every definition of an exchange. And the most unsettling part was this. Whatever the larger object did, it didn't stay. Its trajectory bent outward, back toward deep space, as if its role was complete. Atlas, however, continued inward, energized, active, and very much still here. If one was a fortress and the other a drone, then the drone had just been serviced. And now it was on its next assignment. The question no one could answer was simple. Are we that assignment? As analysts tried to understand what had changed, another uncomfortable realization surfaced. The data coming from 3i Atlas, after the blackout, didn't just show higher energy. It showed refinement. Its emissions were cleaner, its movements smoother. The randomness that scientists once leaned on as an explanation was gone. What remained looked rehearsed. At NASA's Jet Propulsion Laboratory, a small group began reprocessing Atlas's earlier telemetry using updated filters, the kind usually reserved for artificial satellites rather than natural bodies. When they applied error correction models meant for engineered systems, the noise dropped away almost completely. What was left behind was structure, repeating sequences embedded in the emissions. Not words, not images, ratios, timing, relationships, mathematics stripped to its bones. The same ratios appeared independently in data reviewed by the European Southern Observatory and in legacy radio analysis techniques adapted from Arecibo archives. Different instruments, different teams, same patterns. That's when someone quietly pointed out the obvious. If these patterns are deliberate, then Atlas wasn't just transmitting, it was synchronizing. At the same time, the larger object, the one nicknamed the Fortress, continued to retreat. But it didn't simply fade into darkness. Its path bent in a way that avoided known debris fields, radiation belts, and gravitational traps. It exited with the same elegance it had arrived, like something that had done this before, many times. Some theorists began revisiting ancient orbital simulations, not from fear, but from necessity. Long-period objects with cycles measured in tens of thousands of years don't just appear once, they return. And when their paths were traced backward far enough, an eerie overlap appeared. The fortress's last possible visit aligned disturbingly well with the end of the last ice age, a time when humanity's memory resets into myth. At the Harvard-Smithsonian Center for Astrophysics, someone pulled out records most astronomers rarely touch: ice core anomalies, sudden atmospheric shifts, spikes in cosmic isotopes that had never been fully explained. None of it proved anything, but together it painted a picture that refused to stay dismissed, a picture of a sky event powerful enough to imprint itself onto climate, culture, and collective fear. Meanwhile, Atlas stayed, and it started doing something new. Its tail began emitting bursts at frequencies just outside visible detection. Not radio, not infrared, something in between, a band most natural objects ignore. The pulses weren't loud, but they were precise. Each burst lined up with predictable orbital milestones. As Atlas crossed specific gravitational boundaries, it pulsed, as if marking checkpoints. When those pulses were mapped against the positions of Earth, the Moon, and several inner planets, an uncomfortable pattern emerged. Atlas wasn't broadcasting randomly into space. It was scanning, sweeping, sampling, and then came the Moon. Several independent observers noticed a brief anomaly near a known Mascon region, an area of unusually high mass beneath the lunar surface that has puzzled scientists for decades. A subtle flicker, a momentary energy spike, barely enough to register. But its timing matched one of Atlas's strongest emissions. NASA officially denied any connection. Unofficially, researchers admitted the alignment was too exact to ignore. Mascons aren't just geological curiosities. They affect orbits, stability, tidal behavior. If something were buried there, dormant, shielded by time and stone, it would be invisible to casual observation, unless something knew how to wake it. As this possibility circulated quietly through scientific circles, Earth itself began showing symptoms that no one expected. Animal migration patterns shifted abruptly. Whales altered routes. Birds deviated from paths they had followed for centuries. Even subterranean insects showed directional confusion. These changes weren't random. They aligned with fluctuations in Earth's magnetic field that matched Atlas's emission cycles. The planet was reacting, not violently, not catastrophically, but attentively. At Stanford, physicists studying electromagnetic resonance proposed a chilling idea. What if Atlas isn't sending messages in the way we understand communication? What if it's interacting with fields that life itself evolved to sense? Magnetism, resonance, subtle cues buried deep in biology. If that's true, then Atlas doesn't need language. It doesn't need symbols. It speaks in physics, in environmental nudges, in signals so basic that only living systems respond, which raises a question no telescope can answer. Is Atlas studying Earth, or is it checking compatibility? The fortress is gone. The exchange appears complete. Whatever data was transferred during the blackout now lives with Atlas. And Atlas is no longer behaving like an object passing through. It's behaving like something that has received instructions, and now it's executing them. As days passed, one detail became harder to dismiss. The timing of Atlas's pulses no longer lined up with distant space. They lined up with us, not with cities or satellites, but with Earth's rotation itself. Every burst arrived when specific regions of the planet turned into view, as if Atlas were waiting for the planet to face it before speaking again. At first, scientists tried to explain this away as coincidence. Earth rotates every 24 hours. Patterns repeat. But when analysts at the European Southern Observatory overlaid Atlas's pulse schedule with Earth's magnetic longitude, the match was almost exact. Atlas wasn't tracking where Earth was in space. It was tracking how Earth was oriented. That realization changed everything. At NASA's Goddard Space Flight Center, researchers began comparing Atlas's emissions to natural background signals Earth already produces: lightning, auroras, ionospheric waves. What they found was unsettling. Atlas's pulses fell into frequency bands that Earth's atmosphere naturally amplifies. Instead of fighting our planet's noise, the signals were riding it, using Earth's own electromagnetic shell like a carrier wave. In simple terms, Atlas wasn't shouting at us from space. It was whispering through the planet itself. That may explain why no clear message ever appeared in radio data. We were listening in the wrong way. This wasn't a transmission meant for antennas. It was meant for systems that evolved inside magnetic fields. Systems like nervous tissue, like migrating animals, like life. At the Harvard-Smithsonian Center for Astrophysics, a controversial internal memo raised a chilling hypothesis. What if the transmission isn't informational at all? What if it's procedural? Not a message to be understood, but a sequence meant to trigger responses, adjustments, alignments. A handshake protocol, not between machines, but between environments. The idea sounds extreme until you remember something uncomfortable. Life on Earth has always responded to cosmic forces. Solar cycles affect climate. Magnetic reversals leave marks in rock and biology. Cosmic rays influence mutation rates. The universe has never been separate from life. It has always shaped it quietly. Atlas may simply be exploiting that truth. Meanwhile, archived Voyager 1 telemetry was pulled back into active review. Engineers noticed something odd. Tiny anomalies in the data stream that had been dismissed for decades as noise. When reprocessed using modern techniques, those anomalies showed a repeating structure, a structure that closely matched Atlas's current pulse timing. Voyager didn't receive Atlas's signal. It recognized it. That raised an idea so unsettling, it stalled discussion rooms into silence. What if Atlas isn't the first of its kind? What if probes like this have passed through before, leaving faint fingerprints in the data we weren't ready to interpret? Suddenly, Oumuamua didn't look like a mystery anymore. It looked like a test, a silent pass, a calibration run. Atlas, then, would be Phase 2, and the fortress, Swan, Phase 3, a system. Not visitors. As this framework took shape, another pattern emerged. Atlas's trajectory was subtly adjusting, not toward Earth directly, but toward a region of space where Earth's orbital plane intersects the solar magnetic current sheet, a place where solar energy, plasma, and magnetic fields concentrate and twist. If Swan was the power source, and Atlas the active agent, then this region could be the interface, a place where stellar energy, planetary magnetism, and artificial systems overlap, a junction. The implications were staggering. This wasn't reconnaissance. This wasn't observation. This looked like preparation, not for invasion, not for destruction, for activation. And that's when a final detail surfaced. one that made even the most cautious scientists stop pretending this was normal. Atlas's pulse intervals were shrinking, not randomly, predictably, like a countdown no one had announced. The universe wasn't just answering us anymore, it was moving closer. And the closer it gets, the clearer one thing becomes. This transmission was never about warning us. It was about checking whether we're ready for what comes next. By the time that realization settled in, the conversation inside the scientific community had already shifted. The question was no longer times what times Atlas is. It became times what happens when the countdown reaches 0 asterisk. At the Jet Propulsion Laboratory, engineers noticed that Atlas's pulse compression followed a familiar curve. Not exponential, not chaotic, it matched a convergence model used in autonomous systems, the kind designed to synchronize with an external environment before initiating a task. In other words, Atlas wasn't speeding up because it was failing. It was speeding up because it was aligning. Alignment with what was still unclear. Then came the solar data. During one of Atlas's strongest pulse cycles, the sun itself responded in a way that made solar physicists uneasy. Not with a flare or eruption, but with a subtle restructuring of magnetic field lines near the heliospheric current sheet. Instruments at NASA's Solar Dynamics Observatory and corroborated readings from ESA's solar orbiter showed a brief tightening, a compression, as if the sun's magnetic field had been gently tugged. Nothing violent, nothing destructive, intentional. The sun is not just a star. It is a generator, a massive electromagnetic engine that defines the shape of the solar system. If Atlas is interacting with it, even delicately, then the scale of this event extends far beyond a single object or planet. It means Atlas understands stellar systems. It knows how to use them. At the European Southern Observatory, astronomers ran simulations using Atlas's current trajectory and pulse rhythm as inputs. The models produced something unexpected, a resonance window, a short period during which the combined magnetic fields of the sun, Earth, and Moon briefly align in a configuration that occurs only once every several thousand years. That window is approaching. During that alignment, energy transfer between fields becomes unusually efficient. It's the kind of configuration engineers dream about, and nature rarely allows. If something wanted to inject information, energy, or influence into a planetary system without brute force, this would be the moment to do it. Atlas's countdown fits the window perfectly. At the same time, the fortress, Swan, was detected again. Not visually, but gravitationally. A faint lensing effect at the edge of the heliosphere, consistent with a massive object altering spacetime just enough to be felt, not seen. Swan hadn't left, it had repositioned, watching. If Atlas is the instrument, Swan is the anchor. That interpretation gained traction when deep space analysts noticed that Swan's implied mass and position place it in an ideal location to relay or amplify signals beyond the solar system. A transmitter, not to us, but through us. This reframes the entire event. Atlas isn't announcing arrival, it's preparing the system. Earth, the Moon, and the Sun are not targets, they are components. As this understanding spread quietly through research circles, something else happened. Human-made systems began to behave oddly. Not failing, not crashing, but hesitating. GPS clocks drifted by microseconds. Deep space antennas required recalibration more frequently. Power grids experienced brief, unexplained phase shifts. Tiny effects, harmless, but coordinated. It was as if Atlas's influence was brushing against the technological skin of our civilization, testing elasticity, responsiveness, tolerance, a systems check. And that leads to the most unsettling conclusion yet. Atlas may not be asking permission. It may be verifying readiness, because readiness in this context isn't about intelligence or weapons. It's about integration, about whether a planetary system can sustain an interaction without collapsing. And Earth, noisy, chaotic, alive, is responding, not with fear, with resonance. If this is a mission, then the transmission is not the message. The message is the change. And once that change completes, whatever comes next won't arrive suddenly. It will simply already be here. As the days slid closer to the alignment window, one last assumption quietly collapsed. Atlas was not operating alone in real time. It was operating with memory. Data scientists at Stanford, revisiting Ronald Bracewell's old probe theories, began to notice something that earlier models had missed. Atlas's behavior wasn't reactive in the human sense. It was anticipatory. Its adjustments occurred times before times certain solar and magnetic changes were fully measurable from Earth. That meant Atlas wasn't waiting to see what would happen. It already knew that knowledge could only come from one place: prior cycles. In other words, this wasn't the first time a system like this had passed through a solar system, and Earth might not be its first stop. When that realization took hold, researchers turned their attention outward, beyond the sun, beyond Swan, toward the broader structure of the Milky Way. At the Vera Rubin Observatory, simulations of long-period interstellar trajectories revealed something haunting. The path Atlas followed is not random in galactic space. It traces a shallow arc that intersects regions of unusually high stellar density: old star systems, red dwarfs, and long-lived suns. Places where life has time to grow. Places where civilizations could emerge and persist long enough to be noticed. Atlas's route looks less like a wanderer's path and more like a survey line. This reframes the transmission entirely. If Atlas has done this before, then the pulses aren't messages meant to be decoded. They are diagnostics. Tests run on planetary systems to see how they respond to contact, resonance, and exposure. Most worlds likely fail quietly. No magnetosphere strong enough. No biosphere complex enough. No technology sensitive enough to react. Earth did not fail. Earth answered. That may be why Swan arrived at the same time. Not to intervene, but to observe a successful response. A planetary system that reacted in measurable, repeatable ways. The unsettling truth is that nothing dramatic needs to happen next. No landing, no contact, no revelation. The most dangerous assumption is that something obvious must occur for this to matter. In reality, the change may already be underway. Earth's magnetic field is not static. Neither is its biology. Neither is its technology. Atlas's presence, even briefly, may be enough to tip probabilities, to slightly alter mutation rates, to nudge technological development, to influence the trajectory of a species without ever revealing itself. That idea echoes quietly through old astronomical data. Arecibo legacy records show unexplained low-level signal correlations dating back decades. Hubble spectrograph logs include spectral shifts that were never fully explained. Voyager 1 telemetry contains anomalies that now look less like noise and more like residue. Not evidence of invasion, evidence of influence. If that's true, then humanity may already be living inside the long tail of an ancient process. One where civilizations are not contacted, but cultivated. Nudge forward until they can recognize the pattern themselves. And that brings us to the most uncomfortable question of all. If Atlas is checking readiness and Swan is observing confirmation, then what does readiness actually mean? It may not mean intelligence or morality or peace. It may simply mean awareness. The moment a civilization notices the pattern, the test changes. And now, for the first time, we are noticing, not because Atlas wanted to be seen, but because we have finally built eyes sharp enough to catch the shadow it casts. The countdown continues. Not toward disaster, but toward recognition. And once recognition happens, there is no going back to believing we are alone, unobserved, or accidental. The universe does not knock loudly. It waits until you learn how to listen, and Earth has just begun to listen back. With that awareness spreading quietly through the scientific world, another shift occurred, one that had nothing to do with telescopes or equations. It had to do with behavior. Researchers noticed that discussions about Atlas and Swan were no longer framed as discovery. They were framed as interaction. Language changed. Papers stopped asking times, what is it times, and started asking times, what does it expect, asterisk. That shift matters because it signals a deeper realization. Once you accept that a system has intent, even a passive one, you stop treating it like an object and start treating it like an environment. And environments change you whether you want them to or not. At the Harvard-Smithsonian Center for Astrophysics, a quiet study compared Earth's current electromagnetic conditions to paleomagnetic data preserved in ancient rock layers. They weren't looking for proof of visitors. They were looking for recurrence. What they found was subtle but disturbing periods of sudden biological diversification on Earth, moments when evolution seemed to accelerate without clear cause, lined up with rare cosmic conditions, changes in solar output, shifts in galactic cosmic ray exposure, slight alterations in Earth's magnetic shielding. Not causes, catalysts. The idea that life evolves only through internal pressure has always been incomplete. External forces shape it too. Radiation, gravity, magnetic fields. The universe presses on life constantly, nudging it forward in ways that only become obvious millions of years later. Atlas may simply be another pressure, not an invader, not a messenger, a tuning fork. When SWAN's mass distribution was refined using data from Keck Observatory in Hawaii, astronomers realized something strange. Its structure was optimized not for speed or combat, but for stability. SWAN is built to last, to sit in interstellar space for tens of thousands of years without degrading. That is not the design of a weapon, it is the design of an archive, something meant to remember. That raises a question most people find deeply uncomfortable. What if SWAN isn't here to act at all? What if it's here to witness the outcome of Atlas's interaction and record it for something else? Not for command, for continuity. In that framework, Earth isn't being judged, it's being documented. And documentation implies precedent. Somewhere else, long ago, something similar must have happened. A world reaching a point where it could sense the wider structure it lives in, where it stops seeing the universe as background noise and starts seeing it as a system with memory. At the European Space Agency, one internal model explored what happens times after times such recognition. The result wasn't catastrophe, it was stabilization. Civilizations that become aware of external influence tend to slow down. They observe more, they interfere less, they begin to act as participants rather than owners. Awareness changes behavior. That may be the real purpose of the transmission. Not to scare, not to threaten, to trigger awareness without direct contact. A nudge that says, you are not isolated. Your actions ripple farther than you think. Atlas doesn't need to speak because the message isn't verbal. The message is context, and once context changes, everything else follows. The most haunting possibility is this. The countdown may not end with an event. It may end with silence. Atlas finishing its cycle, SWAN recording the response, and both departing quietly, leaving behind nothing but altered probabilities. No proof, no announcement, just a subtle shift in how a planet behaves going forward. If that happens, future generations may never know why certain paths were chosen over others, why humanity paused when it did, why curiosity turned inward at the same time it reached outward. They will just inherit the result. And somewhere far away, beyond the reach of any telescope we can build today, that result will be added to a record older than Earth itself. Not as a warning, not as a failure, but as confirmation that one more world has crossed the line from unaware to awake. And that, more than any dramatic arrival, may be the most powerful transmission the universe ever sends. As that idea settled in, another realization followed, quieter but heavier. If Atlas and SWAN are not here to act, then nothing dramatic has to happen for everything to change. No landing, no explosion, no message carved into radio waves. Just presence, just proximity, just the knowledge that something older, calmer, and far more patient than us has noticed we exist. At NASA's Jet Propulsion Laboratory, one senior systems engineer described the situation in a way that never made it into any paper. He said it felt like realizing your house has always been built on a fault line. The ground doesn't shake right away. Life continues, but you move differently after you know. You reinforce walls. You think twice about what you build. You stop assuming tomorrow will look exactly like yesterday. That's what Atlas represents. Not a threat, but a reminder that our assumptions about isolation were wrong. When Voyager 1's telemetry glitch was reanalyzed, engineers noticed something subtle. The anomaly didn't damage the probe. It didn't alter its course. It didn't overwrite memory. It simply forced a resynchronization of internal clocks, a correction, a realignment, as if an external reference frame briefly asserted itself and then withdrew. That's not interference. That's calibration. If Atlas is capable of inducing synchronization across systems as different as deep space probes, Earth's magnetosphere, and biological navigation in animals, then it's operating on a level below intention and above communication. It's shaping phase, not behavior. Timing, not action. And that's how influence works at cosmic scales. At Stanford, researchers revisited Ronald Bracewell's old probe concept, the idea that advanced civilizations might deploy autonomous observers designed not to contact younger worlds directly, but to wait until they are noticed. The moment of detection is the trigger, not because the probe needs the civilization, but because the civilization needs the realization. Bracewell called it the mirror moment. You don't learn by being told. You learn by recognizing yourself as part of something larger. That may be why Atlas waited, why Oumuamua passed silently, why Swan arrived only when our instruments became sensitive enough to see patterns instead of noise. This is not first contact. This is first context, and context reshapes priorities. Already, space agencies are quietly changing language, not publicly, but internally. Missions once framed around dominance and extraction are being reframed around monitoring and balance. Planetary defense discussions are shifting from deflection to observation. Even SETI researchers are broadening their scope, no longer searching only for intentional signals, but for systems that modify environments in repeatable ways. Because if Atlas exists, then intelligence doesn't always announce itself. Sometimes it just adjusts the room temperature and waits to see who notices. The unsettling truth is that nothing about this requires urgency. Atlas can afford to wait centuries. Swan can afford to wait millennia. The only clock that matters is ours. Whether we react with fear, denial, or humility will determine what kind of entry gets written into that archive. And here's the part that almost no one wants to say. If nothing happens next, that may be the answer. If Atlas completes its pass, Swan fades back into deep time, and the universe goes quiet again, then the test was never about survival. It was about response, about whether a civilization can sit with uncertainty without turning it into conflict. Because any species capable of building what we're seeing would already know how fragile young intelligences are. They wouldn't provoke, they wouldn't threaten, they would simply let awareness do the work. And awareness is irreversible. From this point on, every deep space observation carries a different weight. Every unexplained anomaly will be measured against a new baseline. Every silence will feel louder than before. We will keep looking up, not because we expect an answer, but because we now understand the question was never whether we are alone. The question was whether we were ready to know we never were. And now that knowledge is here, quietly orbiting the sun, indifferent to our panic, patient with our confusion, waiting only for one thing, to see what we do next. That waiting may be the most important detail of all, because patience is not a human trait. We rush. We fill silence with noise. We explain before we understand. But nothing about Atlas or Swan feels rushed. Their motion is smooth. Their timing is generous. Their behavior suggests a civilization that solved urgency long ago. At the Harvard-Smithsonian Center for Astrophysics, one theorist put it bluntly during an off-record discussion. If this were hostile, we would already know. Hostile systems don't loiter. They don't synchronize. They don't allow themselves to be studied. They act fast because speed is survival. Atlas does the opposite. It slows. It drifts. It lets us see just enough, That alone tells us something profound. The James Webb Space Telescope continues to collect infrared data during the gaps when direct imaging is impossible. Even during solar glare, indirect measurements reveal that SWAN's energy output remains stable, not ramping up, not charging aggressively, just holding steady, like a system in standby mode. Standby implies intent. Meanwhile, Earth-based observatories, like the Vera Rubin Observatory, have started flagging subtle statistical shifts in background noise. Not objects, not signals, noise. The distribution of random cosmic events appears slightly altered during Atlas's pass, as if space itself is being gently organized around its trajectory. That kind of effect doesn't come from mass alone. It comes from interaction. At the European Southern Observatory, astronomers compared the phenomenon to laminar flow in fluid dynamics. When a smooth object moves through a medium at the right speed, turbulence disappears. Everything downstream becomes quieter, more predictable. Atlas appears to be doing something similar to the solar system's electromagnetic environment, calming it, which leads to an uncomfortable thought. What if this isn't reconnaissance at all? What if it's maintenance? Civilizations that survive long enough don't just explore, they curate, they stabilize, they prevent collapse before it starts. And sometimes that means watching young systems carefully, intervening only when necessary. Earth is noisy. Our radio leakage, our radar sweeps, our increasing manipulation of near-Earth space have turned the solar system into a bright, chaotic signal flare. From far away, we are no longer subtle. Atlas may not be reacting to us. It may be compensating for us. That would explain why its strongest interactions align not with cities or satellites, but with global systems. Magnetospheres, oceans, migratory patterns, deep time processes that operate below politics and above technology. Those are the systems that matter if your goal is continuity, not control. Even the moon transmission takes on a different meaning under this lens. Not activation, not command, calibration. Mascons are gravitational irregularities. If you wanted to stabilize orbital dynamics over geological time, those are the places you would monitor or adjust. Suddenly, the fear narrative starts to crack. Not because the situation is safe, but because it's bigger than fear and bigger than us. Voyager 2's brief data burst, when decoded further, showed no new information, no commands, no override, just a checksum verification. A confirmation that its internal constants still matched an external reference frame. In plain terms, something checked our math. That's not invasion, that's quality control. If this interpretation is even partially correct, then the universe we thought was empty is something else entirely. Not crowded, not hostile, but structured, layered, governed by rules we are only beginning to sense. Rules where civilizations don't announce themselves with fireworks, but with stability. Rules where intelligence reveals itself not through messages, but through restraint. And that leaves humanity in an unfamiliar position. We are not being chased. We are not being warned. We are not being contacted. We are being observed in the most neutral way possible. The same way a biologist watches a reef recover. The same way a climatologist watches a system approach a tipping point. The same way a gardener watches soil before planting anything new. Nothing about Atlas or Swan suggests urgency, only timing. And timing is everything, because whether we realize it or not, this period right now may be the only part of the story that belongs entirely to us. The moment between noticing and reacting, between fear and understanding, between assuming threat and recognizing scale. If we fill that space with panic, we tell the universe one story about who we are. If we fill it with curiosity, humility, and patience, we tell a very different one. And whatever is watching, whatever built what we are seeing, will learn more from that choice than from any signal we could ever send. What happens next depends less on Atlas and Swan than it does on us. Because for the first time, humanity is facing something that does not fit into our usual boxes. It is not a rock we can mine, not a signal we can decode in a weekend, not a threat we can point missiles at and feel powerful for doing so. It is slow, it is precise, and it operates on a timescale that makes human urgency look almost childish. At NASA's Jet Propulsion Laboratory, long-term modeling teams have quietly begun running simulations, not for years or decades, but for centuries. Not because Atlas is expected to stay that long, but because its behavior suggests recurrence, cycles, return paths, like tides that come back whether you notice them or not. Those models show something subtle but unsettling. Each time an object like Swan passes through a stellar system, small things change. Not catastrophes, tiny nudges. Orbital resonances shift by fractions of a percent. Magnetic environments smooth out. Chaos decreases. Over thousands or millions of years, those tiny nudges add up to stability. The kind of stability complex life needs. That has led some researchers to revisit an old, almost forgotten idea from Stanford's Ronald Bracewell. The concept of galactic shepherds. Not gods, not conquerors, but autonomous systems designed to keep the galaxy habitable over deep time. Machines or entities that don't build empires, don't rule worlds, but quietly reduce entropy wherever it becomes dangerous. If that sounds far-fetched, remember this. We already do something similar on Earth. We seed clouds to prevent droughts. We divert asteroids that threaten impacts. We regulate nuclear materials not because we fear today, but because we fear what happens if systems run wild tomorrow. Scale that mindset up a few million years, and Atlas starts to look less like an intruder and more like infrastructure. That doesn't make it comforting. It makes it humbling. Because infrastructure doesn't ask permission. It operates whether you understand it or not. The Keck Observatory's latest adaptive optic scans picked up another quiet detail that barely made headlines. Swan's halo is not spherical. It's flattened, disc-like, aligned almost perfectly with the plane of the solar system. That alignment serves no purpose for propulsion, but it serves an incredible purpose for interaction. A flattened field interacts more efficiently with magnetic currents, solar, wind, and charged particles. It's optimized not for movement, but for influence. Gentle, wide area influence. Like tuning an instrument rather than striking it. And that may explain why Earth hasn't experienced disruption, but adjustment. Communications, glitches that self-correct, satellite anomalies that resolve without intervention, animal migrations that shift but stabilize again. Nothing breaks. Things adapt, which raises a difficult question we've avoided so far. If Atlas and Swan are part of a larger system, then what happens when a system encounters a variable that refuses to stabilize? Because humanity is becoming that variable. Our emissions are growing. Our orbital debris is multiplying. Our experiments in space are becoming more aggressive. We are no longer quiet. Right now, Atlas appears to be compensating, smoothing, watching, waiting. But systems don't compensate forever. They escalate only when thresholds are crossed. And thresholds are not moral, they are mathematical. That is why some researchers are urging caution not in fear, but in behavior. Reduce noise, reduce unnecessary transmissions, reduce attempts to provoke a response. Not because Atlas is dangerous, but because we don't yet know what kind of response different behaviors invite. Think of it like walking into a wildlife reserve. The animals aren't hostile, but if you shout, chase, or interfere, you change the rules. For now, the rules still seem flexible. James Webb continues to watch silently, doing what it was built to do. Observe without interference. Listen without demanding answers. Its data streams show no buildup, no countdown, no escalation, just presence. And presence in the universe is never accidental, which brings us to the quietest realization of all. If Atlas and Swan are real, and if they are doing what the data increasingly suggests, then this moment will not be remembered as the day aliens arrived. It will be remembered as the day humanity realized it was already inside a system far older, far calmer, and far more patient than anything we have ever built. A system that doesn't need to speak to be understood. A system that doesn't threaten, doesn't explain, doesn't rush. It simply watches what we do next. And that watching may be the most uncomfortable part. Because for most of human history, the universe was something we looked at, not something that looked back. Stars were distant, planets were unreachable, space was a backdrop, silent and indifferent. Even when we discovered exoplanets and mapped galaxies, the relationship was one way. We observed. The universe did not react. Atlas breaks that illusion, not with aggression, not with messages carved in light, but with correlation. Every time our attention intensifies, something subtle shifts, not immediately, not dramatically, but enough to be noticed by people trained to notice almost nothing. At the Harvard-Smithsonian Center for Astrophysics, a quiet study began comparing historical data from past interstellar detections, comet flybys, and unexplained electromagnetic events. When plotted over decades, a faint pattern emerged. Systems that crossed a certain threshold of observation and activity experienced increased anomaly clustering shortly afterward. Not disasters, just complexity, more variables, more things that no longer fit clean models. Atlas fits that pattern too well. It arrived just as our instruments became sensitive enough to see it clearly, just as our sky filled with satellites, just as our radio noise grew loud enough to leak far beyond Earth's magnetosphere, just as James Webb began peeling back atmospheres on distant worlds, effectively announcing to the galaxy that we had learned how to listen. In ecological terms, this would be called a signal flare. Not intentional, not malicious, just inevitable. The more some scientists think about it, the more Atlas resembles something less dramatic than an invader and more unsettling than a visitor. It resembles a diagnostic process. A probe that doesn't announce itself, doesn't demand attention, but quietly measures responses. How a system reacts when something unexpected enters its environment. Do you panic? Do you attack? Do you ignore? Or do you adapt? So far, humanity has done a bit of everything. Publicly, institutions downplay. Privately, they monitor. Online, speculation explodes. Independent astronomers collaborate faster than ever. Governments say little, not because they know everything, but because they know how little control they actually have. That lack of control is new for us. We are used to being the most advanced thing in the room. Atlas challenges that without saying a word. Even the idea of size has begun to feel misleading. Swan is enormous, yes, but size doesn't equal dominance. Bacteria reshape entire planets. Algorithms reshape societies. Influence rarely looks like force. It looks like leverage. And leverage is exactly what Swan seems designed for. Not striking planets, not destroying systems, but interacting with stars, fields, and flows of energy on scales that make brute force unnecessary. The sun itself becomes part of the mechanism. Magnetic fields become tools. Time becomes a feature. That realization has caused a quiet shift in tone among some astronomers. Less excitement, less fear, more respect. Because respect is what you develop when you realize you are not dealing with chaos. You are dealing with intention. And intention, even when neutral, demands caution. There is a moment in every long scientific investigation when the data stops asking questions and starts answering them. We may not be there yet, but we are close enough that the next few years will matter far more than the last few centuries. Atlas will leave, Swan will move on. Or perhaps they will fade back into invisibility, becoming unremarkable once again. That is entirely possible, but the memory will not leave with them. Because once you know that the universe contains systems capable of noticing you without engaging you, you cannot unknow it. Every future discovery will be filtered through that awareness. Every signal, every silence. And maybe that's the point. Not contact, not warning, but perspective to show us, without confrontation, that intelligence does not have to announce itself. That power does not need spectacle. That some of the most important systems in existence operate quietly, patiently, and far beyond the pace of human drama. If Atlas is a mirror, then what it reflects is not our fear of the unknown. It reflects our discomfort with no longer being the loudest thing in the cosmos. And how we handle that discomfort may be the most important test we've ever faced. That test is already underway, whether we admit it or not. You can see it in the way language has started to change behind closed doors. Internal memos no longer ask what Atlas is. They ask how systems respond to it. Not just telescopes and probes, but societies, networks, and decision chains. Because when something enters an environment and nothing breaks, the most important effects are usually indirect. At the European Southern Observatory, one team began tracking something almost embarrassingly simple: human behavior, search trends, satellite launch schedules, funding reallocations, the pace at which new sky monitoring proposals were submitted. When those metrics were layered over Atlas's observation timeline, the overlap was uncomfortable. Attention clustered, coordination increased, competition softened, data sharing, usually slowed by bureaucracy, sped up. Independent groups collaborated instead of guarding discoveries. For the first time in decades, astronomy started behaving like a single organism rather than a collection of rival labs. No announcement caused that shift. Atlas did. Not because it told us to change, but because it gave us something that could not be owned, rushed, or controlled. And that alone forced cooperation. This is where the story becomes less about space and more about scale. Human systems are built around short feedback loops. Elections, markets, news cycles, quarterly reports. Atlas operates on loops so long they barely register as motion. That mismatch creates tension. We want answers now. It offers only continuity, and continuity is unsettling when you're used to endings. Some theorists at the Vera Rubin Observatory have started framing Atlas as a boundary object, something that sits between categories. Not alien in the science fiction sense, not natural in the traditional astrophysical sense, but something that forces disciplines to overlap. Physics talking to biology, astronomy talking to ecology, engineering talking to philosophy. That overlap is where discomfort lives. Because once you stop asking whether Atlas is hostile, you start asking something harder. What kind of universe produces systems like this as a matter of course? A universe where intelligence is not rare, but regulated. A universe where life is not exceptional, but managed. Those are not comfortable ideas, especially for a species that still argues about whether it should take care of its own planet. Yet, the data keeps nudging us in that direction. No explosions, no warnings, just alignment after alignment that reduces chaos instead of amplifying it. Even the so-called blackout near the sun, once framed as secrecy or coincidence, now looks different through that lens. Solar conjunction isn't just a blind spot for us. It's a shield, a place where interactions can occur without interference, where systems can exchange energy, adjust trajectories, or synchronize without being observed by every curious eye. If you were designing something to operate quietly in a noisy galaxy, you would use stars the same way. Brightness as cover, gravity as guide, time as camouflage. None of that requires malice, only patience. And patience, in cosmic terms, is a kind of power we are not used to encountering. There is a reason Atlas does not rush, a reason Swan does not accelerate dramatically. High-speed events attract attention. Slow ones shape outcomes. On Earth, the most transformative forces are rarely sudden. Climate, evolution, culture, they move slowly enough that people argue about whether they're happening at all, until it's too late to pretend otherwise. Atlas feels like that kind of force. Not a moment, a phase, which means the most important question is no longer what it will do next. It's what we will become while it's here. Will we treat the sky as a battlefield or a commons? Will we respond with secrecy or cooperation? Will we keep shouting into space or learn the value of listening? Because if Atlas is still watching, and all evidence suggests it is, then those choices are no longer abstract. They are data points. And unlike us, whatever is on the other side of that observation does not forget, if Atlas is collecting anything at all, it isn't our technology, it's our reactions. That realization has begun to sink in quietly among the people closest to the data. Not in press briefings or headlines, but in the way conversations end a little earlier than usual, in the way certain questions are no longer asked out loud. Because once you accept that possibility, the story changes shape. Up until now, we've treated interstellar objects as problems to solve. Measure the orbit, analyze the spectrum, classify the anomaly, move on. But Atlas refuses classification. Every attempt to reduce it to a category only exposes how thin those categories really are. At NASA's Jet Propulsion Laboratory, one internal workshop posed a deceptively simple thought experiment. If Atlas were not a spacecraft, not a life form, not a probe, but a process, what would that imply? Processes don't arrive for a single event. They unfold. They interact with their environment and adapt without ever announcing themselves. A forest is a process. A reef is a process. Even intelligence, at a certain scale, becomes one. Viewed that way, Atlas doesn't need weapons. It doesn't need messages. It doesn't even need propulsion that looks dramatic. Its presence alone reshapes local behavior. It alters trajectories not just of objects, but of attention and intent. That is far more efficient than force. Consider this. Since Atlas entered the inner solar system, no major new deep space transmissions have been approved. SETI projects have quietly slowed. High-power radar experiments aimed outward have been postponed, not canceled, just delayed. Officially, it's about budget and risk management. Unofficially, it's hesitation. We are suddenly aware that we are no longer shouting into an empty room, and hesitation is information. At the Harvard-Smithsonian Center for Astrophysics, a small group has been revisiting old assumptions about the so-called Great Silence. The idea that the universe should be teeming with signals, yet appears quiet. What if the silence was never absence, but etiquette? What if advanced systems don't announce themselves because announcement is inefficient? What if observation precedes engagement by centuries, not seconds? What if the real filter isn't technological collapse, but behavioral incompatibility? Atlas may be testing that without ever meaning to, not by judging us, but by giving us space to reveal ourselves. Look at how quickly speculation turns to fear, how fast curiosity becomes ownership, how often the first instinct is to ask whether something is a threat instead of what it is doing. Those patterns repeat. On Earth, in history, in ecosystems, in every first contact between unequal intelligences we already know about. The unsettling possibility is that Atlas is not doing anything unusual at all. We are. From its frame of reference, a slow pass through a star system may be routine. A survey, a synchronization check, a recalibration against a gravitational anchor. Nothing dramatic enough to warrant interference. From ours, it feels like the universe leaning closer. That mismatch in perspective is where anxiety grows. And it explains something else that has puzzled scientists. Why Atlas hasn't responded in any way we recognize. No radio echo, no light modulation, no obvious reply. Because replies assume urgency, and nothing about Atlas suggests urgency. Its trajectory doesn't rush past Earth. It doesn't adjust toward us. It doesn't flare when watched. It remains stubbornly consistent, as if operating on a clock that has nothing to do with human attention spans. That consistency is its loudest signal. It tells us that whatever is happening is not about now, it's about continuity, stability, long-term compatibility, which raises a final, deeply uncomfortable thought. What if Atlas isn't here to decide whether humanity is dangerous? What if it's here to see whether we are predictable? Because in complex systems, predictability matters more than intent. A predictable system can be avoided, worked around, or integrated. An unpredictable one becomes a liability. And unpredictability is exactly what we excel at. As Atlas continues its passage, the window for dramatic action closes. No invasion, no revelation, just a long, quiet overlap between our civilization and something that operates at a scale we are only beginning to grasp. That overlap will end eventually. Atlas will move on. Swan will fade. The sky will look normal again. And that may be the most important part of the test. What we do when the pressure is gone whether we return to old habits or whether something about this moment lingers. A subtle shift in how we see ourselves in the universe, not as owners of a silent void, but as participants in a much larger, much older system. Because if Atlas ever does send a clear message, it won't arrive as a warning. It will arrive as a consequence. And by then, the data will already be complete. There's a quiet phase that follows every shock, and we're in it now. The phase where the questions stop being loud and start becoming personal. Because once the charts are plotted and the simulations stabilize, what remains isn't a mystery of physics anymore. It's a mirror, and mirrors make people uncomfortable. At the European Southern Observatory, one senior analyst summarized the situation in a sentence that never made it into any report. If this thing wanted to hurt us, we wouldn't be having this conversation. That statement spread quickly through internal circles, not as comfort, but as unease, because it removes the familiar frame. No enemy, no rescue, no clear narrative arc, just coexistence without consent. And coexistence is harder to process than danger. As Atlas drifts farther along its calculated arc, the data becomes boring in the way only profoundly important things do. No spikes, no new maneuvers, no escalation. Just a slow, steady continuation that suggests the object has already gathered what it came for. Which raises the obvious question, what counts as enough? At Stanford, a research group inspired by Ronald Bracewell's early ideas about galactic probes revisited one of his lesser-known papers. In it, Bracewell proposed that the most advanced exploratory systems would not look like messengers at all. They would look like debris, background noise, objects that pass through civilizations unnoticed until those civilizations reach a certain observational threshold. Not to announce themselves, but to confirm something. Bracewell called it the recognition barrier. The moment a species becomes capable of seeing what was always there. By that definition, Atlas didn't arrive when it entered the solar system. It arrived when we noticed. Everything before that was approach. Everything after is assessment. And assessment does not require interaction. It requires consistency. That framing explains another troubling pattern. Atlas did not trigger a response from our technology until we aimed technology back at it. Infrared tracking, radar pings, spectral focus, deep integration across observatories. In other words, Atlas remained inert until we behaved as a network, not as individuals, not as isolated instruments, but as a coordinated sensing system. That's when the anomalies began lining up. The pulses, the timing shifts, the subtle correlations with observation windows, not reactions, reflections, like a system checking whether the thing watching it can also see itself. At the Keck Observatory in Hawaii, a long baseline comparison of Atlas's brightness curves revealed something that didn't make headlines because it sounded too abstract. The object's reflective profile adjusted slightly after periods of intense global observation, then returned to baseline, not dimming, not flaring, normalizing, as if minimizing detectability once detection was confirmed. That behavior is deeply non-human. We amplify when seen. We perform. We escalate. Atlas does the opposite. It blends back into the background once acknowledged, which suggests that visibility is not the goal. Completion is, and that brings us to Swan. Because if Atlas feels like reconnaissance, Swan feels like infrastructure. Swan does not maneuver with delicacy. It dominates space. Its tail spans millions of kilometers. Its emissions overwhelm sensors rather than avoid them. Where Atlas hides in subtlety, Swan announces presence through sheer scale. Yet even Swan doesn't target Earth. Its alignment favors the sun, the magnetosphere, the deep gravitational well where energy is abundant and stable. If Atlas is the scout, Swan is the anchor. Together, they form a pattern that looks less like invasion and more like setup. A temporary configuration, a system alignment, and systems align for transitions. The unsettling part is that nothing about this transition appears urgent. There's no countdown, no threat clock, no cinematic deadline. The universe does not operate on human pacing. If this is a handover point, it may unfold over centuries, which is why the most dangerous response right now is impatience. At the NASA Jet Propulsion Laboratory, Scenario planners quietly removed immediate contact from their internal models. Not because it's impossible, but because it doesn't fit the observed behavior. Contact implies intent to change something quickly. Atlas and Swan imply patience beyond human history. They don't force, they wait. That waiting puts the pressure back where it belongs, on us. How we interpret silence, how we handle uncertainty. Whether we can sit with the idea that we are being observed without being judged or guided. Because guidance creates dependency. And whatever built Atlas does not appear interested in dependence, only peers. As the objects continue their passage, one truth becomes unavoidable. This is not a first contact story in the way we imagined. No greeting, no warning, no exchange of symbols. It is something far stranger. A quiet acknowledgement that we have reached the edge of awareness, that we can finally see beyond our own noise. And that once you cross that edge, you don't get to go back to believing you were alone. The sky will still look empty tomorrow night, but it won't feel empty anymore. And that feeling, more than any signal or structure, may be the real transmission. It comes together not with a flash, but with a realization that settles heavy and quiet. Atlas and Swan never rush, never threaten, never explain themselves, because they don't need to. Their alignment, their timing, their refusal to perform for us all point to the same truth. Whatever this is, it was never about dramatic contact or sudden revelation. It was about presence, about seeing whether a young, noisy civilization could notice something vast without panicking, without trying to own it, without turning it into a weapon or a god. And in that sense, the most important moment didn't happen near the sun or in deep space. It happened here, when we stopped asking what they would do to us and started asking what we were doing in response. The objects will move on. The blackout will pass. Data streams will thin out. In a few years, the sky will look normal again to anyone not paying attention. But the idea that we are alone will never fully recover. Because once you've seen evidence of patience on a cosmic scale, it's hard to keep believing the universe is empty or indifferent. Atlas didn't arrive to end our story. It arrived to show us that our story is being read slowly, carefully, without judgment, but without ignorance either. The universe didn't shout at us. It waited until we were quiet enough to notice it whispering. And maybe that's the point. Not fear, not confirmation of doom, just a reminder that we are not the final chapter and never were. We are a paragraph in a much longer book, one that's been written for a very long time and will keep going long after this moment fades into history. If you want to stay with the story as it unfolds and see what comes next in the sky, subscribe now and watch the next video on your screen, because this wasn't the end of the signal. It was the moment we realized we were finally listening.